panel members to come up to the stage, if we have our panel members around. Thank you. And we've got, who do we have? We've got Dan. Alain. All right. And AC. We're missing one. Oh, we did. We have one. Oh, you're Jamie Dennis. Okay, all right. So, Alain Berinstain from Moon Express, AC Charania of Blue Origin, Jamie Denniston from iSpace, and of course Dan Hendrickson from Astrobotic. Gentlemen, find a space. There's a what?
So iSpace is, I'll explain, iSpace and Team Hakuto are connected.
All right. Let me just, as you may have gathered, I'm going to moderate this, this august panel. And what I would like to do is I'm going to give each one of our panel members 5 minutes to come up and basically tell us what they have on the basis of what we've heard this morning and why they are relevant to our discussions. So we'll start off down here with AC. No pressure, AC. But, then we will get into open discussion.
So do you have a presentation?
All right, go ahead. Do you have any slides?
Yes, I do. And they are up right now, so thanks.
There you go.
So thank you, everyone. Good morning. It's a very exciting time, I think, in the industry and in society in terms of a true return to the moon. I'm AC Charania from Blue Origin. Our vision is millions of people living and working in space, and the time has come to return to the moon, and this time to stay. So, as I said, Blue Origin obviously founded with a larger mission and larger purpose, but within that larger mission and purpose is the exploration of low Earth orbit, is sending satellites to geostationary orbit, is the exploration of cislunar space and the lunar surface to enable this future. This future will not just be enabled by transportation and infrastructure, but by some of what you're doing, science, exploration, ISRU, to enable future industries, future technologies, future capabilities. Jeff Bezos, our founder, founded Amazon, of course, and one of the reasons Amazon was successful is because the foundation of the internet was there, the foundation of TCP/IP, browser technology, electronic payments, and on that framework, Amazon was able to revolutionize the world. So in some sense, our vision of Blue Origin is to enable that foundation of transportation and infrastructure development to enable all of your great ideas and all the great ideas of the future in-space businesses to flourish, to lay that foundation. Now that foundation happens in a kind of process. We have a motto translated to Latin means step by step ferociously. And so we're taking the various steps in terms of engines, structures, avionics to enable these future capabilities. One of those capabilities is New Shepard, this suborbital vehicle that you see here, a LOX hydrogen propulsion module with a crew capsule. We've had multiple flights of this vehicle. We had a flight recently with the next serial number of the propulsion module and crew capsule that you may have seen, and I encourage you to go to YouTube and see it. But these kinds of vertical takeoff, vertical landing technologies, propulsion technologies, other technologies enable other capabilities such as lunar landing. Additionally, we're developing an orbital launch vehicle called New Glenn. This vehicle is designed to launch about 45 metric tons to low Earth orbit with an incredible payload-faring diameter of 7 meters to enable a lot of interesting science ideas, commercial missions, etc. These we can use this launch vehicle to launch some of the lunar missions that we'll talk about. We do believe that these capabilities that we're building build to a larger future. That larger future includes a return to the moon to enable a permanent settlement. A critical technology will be the capability to land repeatedly in specific locations and to have a cadence of missions using a similar architecture. So we're using the technologies that you just saw on New Shepard, New Glenn, our engines programs to put together a lunar architecture. Kind of in an overall summary in terms of Blue Moon, the vision is really cost-effective lunar transportation surface delivery to enable all these great ideas, to enable delivery of the Resource Prospector rover, to enable delivery of an ascent stage that could go to the Deep Space Gateway or come back directly to Earth. We're developing Blue Moon to be an all-lunar capability. It's not designed to just land at the equator. It's not designed to land just at the South Pole. It has a tremendous capability, and we're telling the technical team in terms of the design requirements to put into the mission the capability to grow, the capability to survive the lunar night, to evolve the capability of the mission. The Blue Moon architecture, if launched on a launch vehicle such as the SLS, could land about 10,000 pounds to the lunar surface. Now, you don't have to use it all, but we think that kind of capability of a medium to large lunar lander capability is a nice synergy to some of the other programs that my colleagues will talk about today, to enable larger rovers, multiple rover deliveries, to enable a seismic delivery of a seismic network, and to lay the foundation of ascent stages that could go to the gateway or come back to Earth. So we think this is a very unique time. We as a company have the technologies that we can now combine together along with a partnership with NASA. So we have been active discussions with NASA headquarters and various field centers for technical partnerships on various elements of Blue Moon, as well as our own interest in a public-private partnership where we would put in a non-trivial financial contribution coupled with NASA's contribution to enable a very large lunar lander capability to enable these relevant missions. So I think for us, it's a pretty exciting time. I'm personally excited by my colleagues here and what they're attempting. I think Jeff and the rest of our company are also very excited for New Shepard, for New Glenn, for our engine program, as well as Blue Moon, and to enable this future. And I think with the public-private partnership with NASA, as we've discussed it with them, we can enable a very interesting capability for the next few years. And we can see that not just one mission, but a cadence of missions that build the capability. That's our goal. It's not just a single return, it's a return to enable a permanent presence robotically and eventually with humans as well. So thank you.
Okay, does this, all right, doesn't work. So, we will move on then with Alain Berinstain from Moon Express, and take it away, Alain.
Thank you. I think we have some slides too. Yes, excellent. Thank you. Thank you, and thanks for having us here. I am not Bob Richards, as advertised in your packages. He sends his apologies for not being present. My name is Alain Berinstain. I recently joined Moon Express. After having been a part of the science community for space missions for a while, I was at the Canadian Space Agency for almost 20 years, and now have recently moved my family to Florida to join the Moon Express team. If you're wondering how serious Moon Express might be for the future, I would not move my family to Florida if this was not a serious thing happening. Maybe that's all you need to know. I'll sit down there. So I'll try to make this, I will make this quick. Our vision is really to expand Earth's economic and social sphere to include the moon. We see the moon as the Earth's eighth continent to explore and to also mine for resources like we have with every other continent on Earth. And if we do talk about resources, remember a resource is only a resource if it's actually worth more than what it costs to go get it, wherever it is. And so a lot of our mission has to do with collapsing the cost of accessing the surface of the moon. And we'll do that, we've done that over time. But some of the biggest cost drivers, actually the single biggest cost driver right now is the cost of launch. And if you've been looking at what's happening in the launch arena, that cost is coming down very, very quickly, and that enables missions for the future. To be super clear here, because sometimes we get into this confusion, Moon Express is launcher agnostic, does not, its mission, only its capabilities might change according to the capability of the launcher, but we don't develop launcher systems at all. We've talked a lot about Apollo 17, the importance of that mission and how it changed our view, and I don't need to get into, let's see, just trying to move forward. There we go. I don't need to get into with this crowd, the importance of the diversity of the moon and how interesting it would be to land a lot of missions there and to study it and to eventually settle it. I'd like to get you to the point where we're just going to demonstrate quickly our view of exploring it. And definitely things are changing, especially in the US, leading the world in terms of reopening our eyes to the importance of the moon. The way this is going to be done is through a series of robotic explorers. Imagine an R2-D2 size and shape type single unit that would land, or orbit, or land on the surface of the moon. And those could be combined in a modular fashion, either stacked or arranged. And this is just a quick 1 or 2 minute video to illustrate a little bit. So imagine our first mission being this single module R2-D2 sized lander with to be able to land on the surface with a modest payload capacity, again depending on the launcher that's used to get there. It is able to land and then take off again from that spot to be able to maybe access different locations on the surface of the moon by hopping around that way. That would be the idea of the first mission with all its capabilities. And we're talking 10, 20 kilos of landing capability, again, depending on the launcher that's used. It could access anywhere on the planet, on the moon, because it would start from a lunar polar orbit. You can imagine a South Pole type landed mission and be able to land, of course, in one of these permanently lit areas, and to be able to explore that wonderfully rich scientific location. Now imagine being able to take these and put them together into larger missions. This is just a series of those put together in a 5 or a 9 ring to be able to land much more mass on the surface of the moon. We're talking 300, 500 kilos, and maybe access some samples either directly from the deck or with something that would be deployed, but then putting that back into one of these modules that wasn't used for landing, but is only there to be able to return this sample back to Earth, on a ballistic reentry and an entry capsule that would come off of it. So this is just an idea of the an illustration of the architecture, accessing anywhere on the surface of the moon, and being able to do this cheaply. That's really our goal, is to be able to collapse the cost of a mission. There's a lot more to talk about. We've done a lot of testing. We're really moving forward on the technology and on the funding to be able to make this happen. And we're happy to discuss about scientific opportunities. We have already announced that we'd love to even help to fund some of the payloads that might fly for a science payload that might be selected by NASA. For the first 3 that would be selected, we'd be in for $500,000 of co-funding of each of those payloads on the first few missions. I don't want to go any longer for now. Looking forward to the discussion. There's a lot of great stuff to discuss. Thank you.
Thank you, Alain. Is this on? I have no idea. The lights are on all of them. But anyway, it's on. All right. Okay. We'll go to Dan Hendrickson from Astrobotic next.
Have some slides to bring up. Good morning, everyone. Thanks very much for the opportunity to be here today. This is a very timely workshop. It's a pretty pivotal moment, we think, for the moon and the country and the world. Still waiting on the slide deck here, but just to go ahead and kick off, I'm from Astrobotic. We're a commercial lunar delivery company. We take payloads from around the world. We integrate them on a single lunar lander. This is our lander here, the Peregrine Lunar Lander. Our approach is to take a very modular delivery shipping model approach to delivering payload. So as everyone in this room is quite familiar, in the past, planetary missions and planetary spacecraft have really been designed specifically for one particular payload instrument suite. And then after that mission is over, that design basically goes in the garbage can and you start over again, over and over again. So with our approach, we actually take this modular shipping model approach in which we use the same core spacecraft bus over and over for all of our missions. And the result by doing that and by utilizing a modular delivery vehicle is to reduce the cost of getting to the surface. So we offer $1.2 million per kilogram for pricing for getting to the lunar surface. So as I mentioned, we consider the Peregrine lander essentially a product line. And what we mean by that is all the subsystems that you see here on the left, we utilize the same subsystems each time for each mission. So once you've successfully demonstrated this core spacecraft bus, we then believe then that the user community can rely upon that design over and over again. So once it's been successfully demonstrated, there's no need to reinvent the wheel. There's no need to essentially throw the design in the garbage can. We want to utilize this system over and over. So the subsystems that you see here on the left, the structures, the GNC, the power, the avionics, the prop, the thermal control, the communication system, all of those subsystems make up this core Peregrine spacecraft system. And with this core payload delivery spacecraft bus, you can access all parts of the moon, all mission profiles. So it's possible to go to the far side, it's possible to go to the near side, equatorial, get to close proximity to caves, pits. We really wanted to fundamentally make it accessible with this same spacecraft bus over and over again. So by utilizing this bus, you can see here on the left we have a core bus that we have all those subsystems we use over and over again, those same designs. And then to the right are some of the possible configuration modifications that can be made in addition to the core spacecraft bus. So what you'll see here is that there's significant flexibility to go to multiple different locations by having different modifications of, say, where the solar panel goes for the power system that allows you to go to high latitude or to go to a far side polar location. The middle configuration you see here is an example of this philosophy in action in which we can actually deliver multiple different types of payloads. So you can go, say, instead of maybe just a small collection of payloads, you can also go to a larger, say a 265 kilo rover on the top mount of this middle configuration. So this is really meant to provide sort of three things. Reliability is one. So once we've demonstrated this core spacecraft bus, you can utilize this over and over again and rely upon it because it's been proven on a mission. Second is to continue to use this 1.2 million per kilogram price point over and over again. So you'll notice with these slight modifications, there's very little non-recurring engineering that occurs between spacecraft and between missions. And so there's sort of really not only those two key tenets, but also the ability to then have different types of utility for different payload communities. We don't presume to know exactly all the different uses that a service like this might have for the user community. We're here to serve you and to provide a core spacecraft bus that all the different types of mission profiles, whether those sample return, whether it's resource utilization, all those different types of payload mission profiles are possible for you, for the user community. So this is a quick look at our first mission. This is a key demonstration of service for our Peregrine lunar lander. It's again to test out the payload bus, to also demonstrate the service for use by the payload user community. We'll fly as a secondary payload in Atlas V, of course, one of the most reliable launch vehicles in the space community in history, and also has delivered a whole variety of different spacecraft. The Atlas family has delivered a whole variety of spacecraft to the lunar vicinity. We offer 35 kilos of non-NASA payload capacity on this first mission. We offer the opportunity to do one lunar day or 8 Earth days of surface operations with this first mission. We provide a particular allotment of communications and power for every kilogram that's purchased on the surface. And also we provide about a ½ meter squared on the top and the bottom decks of this spacecraft. So you can see here the top view and the bottom view provide all the different available mounting options for this first mission, which will go to Lacus Mortis at 45 north, 25 east. So we'll start with 35 kilos of non-NASA payload and then have an allotment for NASA as well. What you'll notice here then is we grow with this same spacecraft bus going forward. So by filling the tanks, by taking a different trajectory, we can grow this capacity up to 265 kilos going to any destination on the surface. I'm happy to report that we're now at a preliminary design review level of maturity on the vehicle. These are some of the products we've generated from that review, and this is a true industry standard PDR. And one of the ways, I think, to measure that as a true industry standard PDR is to look at our partners. So we've been working with NASA for 3 fiscal years under the NASA Lunar Catalyst program. That's been a highly successful public-private partnership. It's been a real thrill, and it's been fantastic to work with NASA HEO. We've been really benefited significantly from that. We also are working with Airbus from Bremen. So they provided a number of inputs into our program, but they've also provided independent review teams. So when we say we're at a PDR level, you can go to Airbus and you can ask them. They'll provide that independent review voice for us. We're also working with DHL. That's a corporate sponsorship of ours, so it's an exciting opportunity to have non-space companies be involved in our program, to bring them into the fold and also to bring their funding into the fold. We also have ULA as a partner of ours as well. So again, we're flying on the Atlas V, one of the best launch vehicles in the world, and we're glad to be flying on such a reliable track record. I'm proud to say that we're leading the world in commercial sales for payload deliveries. We have 11 deals currently for our first mission. We have 6 countries that are represented. And I think this is really emblematic of the fact that we're really demonstrating the payload delivery model works. And there's a very wide diversity of different types of customers that are a part of this program. We have international space agencies. We also have small to medium-sized companies, startups, all the way up to established providers. So I think this is proof positive that this is a viable way of opening access to the moon. So all of that commercial progress and all that technical progress that we've been making, we think has really now led us to the position in which NASA has announced they're looking to do payload buys on commercial providers. It's an incredibly exciting time to be discussing these topics here, because now NASA's moving out on it. They said so at a hearing back in September. Jason Crusan from AES, from HEO, had confirmed that in front of the House Space Subcommittee. So it's an incredibly exciting time for us to be having this dialogue with you here in the user community. And so with that in mind, I'd like to offer this resource checklist. So we offer a number of resources as a service provider for you, the user community, right off the bat. We consider the Peregrine Lunar Lander to be the world's most advanced in terms of technical maturity. And so because of that, we can offer you right now a whole variety of products that you can utilize to start preparing your payload for these NASA payload calls. So for instance, the payload user guide for our vehicle, publicly available on our website. We have it here in person. Come get it. Come see us at the poster session. We also have our interface design document, which serves as the precursor to our interface control document. All of this is well prescribed. It's here for you as the user community to begin using right now. And then we also offer resources in the form of our Peregrine CAD file. You can have it. You can start looking at the keep out zones. You can understand what's still available on our mission, because again, we have the 11 deals that are currently in place. All of these resources are available to you now because we consider ourselves a service provider for you. And lastly, I think one of the differentiators I would offer is that we offer very personalized service. So we have a number of folks here from the Astrobotic team. We actually have 5 folks here. Our mission director, Shara Bhaskaran, which many of you are quite familiar with from NASA Ames. He has 25 years of experience putting payloads into space. We also have Jeff Hopkins here, our chief engineer from the program. Come see us at the poster session. Come see our 1-to-1 scale Peregrine Lunar Lander out in the area back there. We'd love to talk about how to get your payload on board Peregrine and really make use of the upcoming payload calls that NASA's offering. Thank you very much.
Thank you, Dan. We'll move on to Jamie from iSpace.
Okay, good morning, everyone. One small clarification on the program, because I think there's maybe some confusion between Team Hakuto and iSpace. So just to explain, Team Hakuto is a team that's involved in the Google Lunar XPRIZE. It's made up of various different entities and organizations, iSpace being one of them, whereas iSpace, as a company, goes beyond the Google XPRIZE, which we'll discuss today. So let me start off actually by introducing the company iSpace. I think we're probably not as well known as some of the other companies on the panel today. So iSpace was founded and is headquartered in Tokyo, Japan. You see, it's not just a Japanese company, it's very international. We have just over 40 employees just now, but it's growing very rapidly. So estimates are that we'll actually almost double in size in 2018. We also have 2 smaller offices, one in Europe and Luxembourg, and one actually here in NASA Ames. So one key milestone for the company was achieved last year in December, which was the successful raising Series A funding of almost $90 million. So that's very important for us as a company, because it's these funds which will be the resources for our first 2 lunar missions, which we'll discuss in this presentation. So in terms of the origins of the company, iSpace really was launched or born out of the Google Lunar XPRIZE. and as I mentioned, as part of this team Hakuto, which was the Japanese team. So Team Hakuto is one of the 5 remaining finalists in the competition. I won't go too much into the XPRIZE, it's not really the topic for today. The key thing I want to mention was the rover, because the rover of the XPRIZE is the basis for our future rover developments, and this is one area where we want to host payloads for the future. So the key thing to say, I think, about the iSpace rover is its small size and mass. Certainly the most impressive thing to me. So the mass of the iSpace rover is only 4 kilograms. A huge amount of effort went into reducing that mass. It's very small. It's only about 50 centimeters by 50 centimeters. And in doing so, they used not only a carbon fiber body, but also you can see, we can't really see from the photo, but plastic wheels. A lot of non-standard materials and manufacturing went in to achieve such a low mass product. See some nice photos here. This is the rover, which has now been shipped to India as part of the Google Lunar XPRIZE. Final acceptance testing was performed at the end of 2017. So we see some images here of the field testing that was done, the TVAC, the vibration testing, all of the environmental tests which were performed at the end of last year. And the rover is now in India to be integrated onto the Team Indus lander for final environmental testing this year. In terms of collaborations, in terms of hosted payloads on the rover, we have 2 already kicked off. So the first is with JAXA, Japanese Space Agency. We've signed an MOU in 2016 to host a radiation counter. In fact, this radiation counter is on the rover we just showed in the previous images. So this will be flying to the moon this year. And also, a second MOU has been signed with the Luxembourg government. There's a lot of collaboration just now between iSpace and Luxembourg. The first key collaboration is to send a neutron spectrometer to the moon. I think the date is something like 2020, where it's planned to be launched. Okay, so that's the status and progress in terms of the rover, but this is, of course, just the first phase of iSpace's vision for the moon. So beyond the Google Lunar XPRIZE, the key vision of iSpace is to, first of all, map the resources on the moon. We've heard quite a lot about resources already. We plan to do that with swarms of these small rovers, these micro rovers that we're producing. We intend to deliver those to the moon ourselves with our own lander technology, which is what we're developing just now. And beyond that, in the longer term, certainly maybe in the 2030 range, we plan to be a key part of the extraction, process, and delivery of those resources. So we can split those phases up into some missions and give you a bit of an idea of the timeline of what we're doing. So M0 we refer to as the Lunar XPRIZE, which is just now, so this year, effectively. Beyond that, we have 2 missions, which we call M1 and M2, and we describe these as our R&D missions. So these 2 missions are planned to validate the lander technology, which we're developing ourselves. We want to demonstrate on board all the hardware and software needed to reach the moon successfully. And then beyond that, mission 3 onwards is when we plan to start commercial missions. We have a very aggressive schedule, as you can see. So M1 is planned to be launched at the end of 2019, and M2 shortly afterwards, 9 months afterwards, in 2020. So focusing on those first 2 missions, what we call the R&D missions, which is certainly my focus at the moment. Broadly speaking, they're split between lunar orbit and lunar landing. The idea is to have an incremental validation of this technology, first reach orbit, and then the second mission demonstrate landing technology. In fact, however, the plan just now, even for mission 1, we are developing the technology needed to attempt the landing on the moon. So already the development of the landing gear, the GNC, etc., is ongoing. Our strong ambition is to be able to perform that landing attempt on M1 at the end of 2019. If schedule constraints don't allow it, the minimum success criteria, let's say, is to reach lunar orbit. And we do plan to have actually some extended period in orbit at the moon on this first mission. But we do plan to attempt the landing as well. Certainly by mission 2, which is due in 2020, we will perform a landing attempt on the moon. I should just quickly maybe apologize for the artistic license used in some of these photos. They clearly weren't produced by an engineer or a scientist, but more to capture the public's attention. A bit of status on M1, which is ongoing just now. So we've passed our first review, which was a joint SDR and SDR. so the design review before PDR. We had involvement from Japanese industry. JAXA was also represented, and it was successful in November last year. We have in our schedule PDR and CDR scheduled for both this year, the beginning and end of the year. And we actually have now started procurements of some of our flight items, particularly in the area of propulsion. So our thrusters, for instance, have now been selected and ordered. So the images we show here, I should point out, are a design concept. So our design concept, where these images were produced from, is now slightly outdated with respect to our current design. The company made the decision to keep the updated design details confidential until our PDR later this year. And so these are the best photos we have to illustrate what the lander looks like today. Some things have evolved. For instance, you can see here this is a two-stage design with all the tanks on the top. Things have moved on since then. We now have a simplified one-stage, much more compact design. The overall dimensions, however, the functionality, the general design, let's say, is quite similar to this. So I think this will give you a good idea of what the lander will look like in the end. Perhaps not so shiny and chrome covered. Again, this is some artist's illustration there. In terms of payload, we plan to take 30 to 50 kilos to the lunar surface. So the minimum is 30, but our structural elements on the spacecraft bus are also being qualified to take slightly more for more favorable launch conditions. We have a dedicated payload deck, which is where we will accommodate both our rovers, and also we're very, of course, interested in taking payloads from external customers. We have a deployable ramp and hold down release mechanism to allow those rovers, of course, to be deployed on the moon once we get there. One particular feature of our design just now is very high bandwidth communications. We have quite advanced talks with potential customers to support HD video streaming from the moon. Probably that's not of huge interest to this community here today, but certainly that high bandwidth communications can be used for science data, and that will be very useful, I think, for certain types of missions. Beyond that, in terms of landing, of course we know that all future lunar missions of any significance require precision landing, also the ability to avoid and detect hazards. So both of those will be performed on board autonomously by algorithms in our spacecraft. In order to achieve our schedule, which is to launch first of all M1 in 2019, we are partnering with another company, a third entity, who will provide those landing GNC algorithms, somebody who has significant expertise and heritage in that area. So that selection was achieved, it was completed earlier this month, in fact. I don't think we can actually say the name of our partner yet, but certainly that is now kicked off and ongoing. In terms of the landing precision, we're targeting 100 meters, and also the hazards of 15-degree slopes and 30 centimeters is what we're shooting for at the moment. I think this is my last slide, actually. In terms of landing sites, certainly I'm not going to talk to this audience today about the merits of different landing sites. The key message we want to get across about the iSpace lunar lander is it's being designed, as we heard in some of the other talks today, to go anywhere with some exceptions. So certainly our first mission is designed to go anywhere in the near side of the moon, because we don't have any relay satellites yet. And also we have no plans at the moment for these first two missions to survive the lunar night. Of course, that's something we're very interested in the longer term. It's not what we are designing for these first two missions. The idea is to land on the near side of the moon for the lunar day, but anywhere between the equator and the poles. One final slide. We are, of course, very excited like everybody else. We think genuinely there's about to be an explosion in this area of lunar exploration. I think we're in the right place at the right time. We're here with two of my colleagues, Toshiki Tanaka and Ryutaro Ichikawa. We'll be very interested to talk with all of you over the next 2 or 3 days. We're very interested to know about what you guys are interested in, what you guys want to see, and that will really guide what we do over the next 2 or 3 years. So thank you very much, and I'll be happy to take some questions.
Okay, it is not the moon your parents knew. It's a different beast. So we're going to open it up for questions. Before we get into questions, I do want there to be questions so that everybody, or as many people as we can fit in, can get a chance. Please do not monologue our panel. If you start off with a monologue, you will be asked to sit down. So questions. Mark, our first monologue. Question.
What do you mean by monologue?
I'll tell you in a minute.
Okay. I was wondering if there's somebody in the room who can clarify what Space Policy Directive 1 means, you know, it was signed December 11th last year, in a practical sense, like over the next 2 years or 3 years, and how these folks fit into that.
Can anybody on our panel address that question?
I'll take a stab at it.
Go at it, Dan.
All right. So I certainly can't speak for the administration or for NASA, but I do think that with the announcement with the directive, I think there's great foundation for utilizing commercial services, because even before that announcement of the directive, there was the announcement by Jason Crusan at the hearing that they're intending to utilize robotic service providers for delivering payload to the moon. So I think regardless of kind of what the master plan is going to look like when we see maybe the president's budget request in February, we're going to see a strong foundation of utilizing robotic services just right out of the gate, because that was already even announced before SPD1. So I know it's a bit of an unsatisfying answer, but I can say at least it is satisfying to know that they're already laying practical plans for a call before there's necessarily like a master plan that SPD1 is outlining.
Okay. David Kring.
I want to address the issue of comm. For example, the last speaker spoke about HD video, and so I'm wondering, are these commercial providers anticipating using the DSN? And I'm also wondering, if we get a constellation of commercial spacecraft in cislunar space, lots of data coming towards the Earth, do we have something other than the DSN to use? For example, are we going to relay through Earth orbiting comm satellites, or do we have some other solution? Do these commercial providers have a solution?
Yeah, so allow me to answer then. I think the short answer is yes, we are interested in the deep space networks. Talks are already underway between iSpace, certainly ESA-TRAC, so the ESA equivalent, I believe also with NASA as well, for our high bandwidth telemetry. We plan also to have a second low bandwidth, low gain antennas, etc., for more standard communication with the Earth. But yes, for the very high bandwidth, we do anticipate just now some use of the deep space networks. Then beyond that, we have a lot of interest, a lot of talks in setting up some kind of relay communication ourselves. It's very early days, of course, but yes, we would be interested in alternatives. Those concrete plans, but yes, there's things we're looking at.
Anybody else? Okay.
There are commercial entities out there that are looking just at the comms aspect that any of us could be partnering with to make that happen. So whether it's baselined in our missions or not, there certainly is the expertise and the plans out there to make it happen. So it'll all be customer driven, and what you need is what we will help make happen. But it could be that one of our customers is one of those high bandwidth communications providers. And so that's the, right now for us anyways, is, you know, we're there for the transportation. We're not baselining the HD type of video high bandwidth right from the very first mission, unless one of our customers is willing to come up with it.
Yeah, I'll add to that as well. From our perspective, we signed a payload, Atlas Space Operations. They're sending a laser communications terminal as a tech demo. So exactly with the model that Alain was just describing, we're doing that now with a tech demo as a payload, but then in the future we might be able to baseline that capability into our lander once we've successfully demoed it as a tech demo as a payload.
I do want to add that I believe that there is a public-private partnership with ESA and Surrey. James, can you just cut in and answer that question, please?
Sure, I'll jump to the front. Yeah, you've accelerated my question or comment. Yes, so there is a public-private partnership which is being set up now between ESA and a consortium of Surrey Satellite Technology in the UK and Goonhilly Earth Station, who have a very large terrestrial ground station, to prepare a commercial communications relay capability for the Moon, which then the target would be to have that launch 2020, 2021 timeframe.
It seems as if there's opportunity to network here with what is going on in Europe as well as...
So one thing to say that first mission would not have massive bandwidth capability, probably, but it's supposed to be the first mission in a global network, which would eventually expand further into deep space as well.
Okay. Thanks, James. Sharon.
Sharon Kudar, JPL. Quick question about lifetime of those landers. Do you see, what is the current lifetimes, and do you see any commercial incentives to extend those lifetimes significantly, say up to a lunar year?
So, okay, so from the iSpace point of view, as I said, the first 2 missions anyway, what we call our R&D missions, are designed just for the lunar day. It's very clear, I listened to the talks this morning already, that there's a huge interest there in longer missions, particularly to survive the lunar night. So already it's something we're starting to discuss. We have teams looking at it, but for us it's something for the future. So certainly in the 2021 onwards time frame.
Yeah, I think for us, we are looking at enhancing capabilities to the first mission, and that would include the capability to provide additional power and resources to payloads to survive the lunar night and to survive long duration extended periods. Once again, we have a larger vision, and that vision, I think, requires the ability to survive the lunar night. It requires the ability to do other things on the lunar surface. So we are looking at those enhancing capabilities from the initial missions outward. So I think, something I take away from Jeff, Jeff typically says, if you provide customers more power and more mass, they'll take it. You know, so I think that's what I look at in terms of our capabilities. That we want to provide this. Now we may not know the exact mission requirements of what customers would want, but if we can offer customers higher power, longer duration power, surviving the lunar night, scientists and customers will take advantage of that. So we are definitely looking at that.
Okay. Brad.
Brad Jolliffe, WashU. I was glad to hear the last speaker talk about precision landing, 100 meters. I wonder if we could hear just a little bit more, perhaps, how does that affect costs, and do you have all the information you need from LRO? You know, what other concerns do you have? And maybe it's a question for any or all, but maybe we could start with Alain.
Sure. The capabilities and development for us to continue to provide higher precision landing over time. And so that's already in play. So it'll be a capability that develops over time.
Maybe go to Jamie next, because you actually put the figure up on the slide.
So yes, the 100 meters is certainly a target. As I mentioned, we've just, as recently as this month, partnered with another company who will be providing the algorithms, the software needed. So we don't have yet the exact number combining the candidate sensors we have with theirs. Certainly, over the last 6 months, we've been in let's say, a study phase with them, and these are the numbers we believe are possible, certainly. Yes, it adds cost, it adds mass for the sensors we need to achieve that kind of accuracy, but we feel for the type of missions that we plan to support, both for the science community and also what we plan to do in terms of resource prospecting, it's essential. So yes, it's a key part of our future plans.
Yeah, so absolutely, it's in an Astrobotic's case, we've been baselining that for future missions and been working pretty steadily on that technology development. In fact, we did the world's first visually guided propulsive landing it was actually in conjunction with Maston on their lander, and our guidance system pioneered that and demonstrated it out at the Mojave Desert. I'd love to maybe show anyone who's interested. We have footage of that test, and we also have here in the audience our future missions and technology development team. They can speak quite at length on the technical details and how we accomplish that, because it's one of our primary areas of expertise as a technology development is concerned.
Okay. AC, anything to add to that?
No, once again, going with our philosophy, which is this longer-term vision of enabling these capabilities, we are looking at precision landing, hazard avoidance, terrain relative nav, the whole suite of technologies that are out there that NASA is investing in that we could leverage for the system. I think we are definitely interested in soft landing on the lunar surface, and the subsequent missions would land very close to those initial missions to start building to have the option to start building a capability at a preferred site. So yeah, we are definitely looking at those technologies.
Thank you, AC. Carl?
No, thanks, Jeff. Three of you talked about getting the moon on rideshares, basically not providing your own launch vehicle. Given that, have you thought about not just going to the moon, but perhaps going to an asteroid, and your lander support that? And finally, a question for Dan. You mentioned 35 kilogram for non-NASA payload. How much for a NASA payload?
Undisclosed on the amount. It's pretty significant. and happy to talk further online or offline about that allotment. But we keep that 35 kilo mark because we want to reduce the complexity and make this as straightforward as a demonstration mission as possible, which is why we take that approach.
So is the NASA over
It's above that 35.
over 100 kilos?
Maybe.
I'm just asking. Oh, always. Okay.
On other destinations, our basic mission architecture assumes getting a ride to low Earth orbit and then going from low Earth orbit to lunar orbit. However, you can think of all kinds of scenarios where that's not absolutely required that you go to lunar orbit. If you start to think also about the Deep Space Gateway, if you start to think about other launching systems, or stacking two of our modules one on the other, then yes, other destinations become possible and of interest. So absolutely, it's possible.
Yeah, I think for us, we do have an interest in leveraging all of our capabilities, not just the Blue Moon capability. For instance, I'll highlight here our LOX hydrogen in-space engine, the BE3U, we're developing at Blue Origin. I'm very excited about that engine because I do believe that's a very, very interesting 120,000-pound thrust level LOX hydrogen high ISP engine that could be used for a lot of interesting in-space missions. We couple that engine and that technology with Blue Moon, with the lander, but we can offer that to other customers for other locations. I think that to me is a pretty interesting deep space capability that we're developing. So.
And a potential user of lunar resources.
There you
go. Jamie, anything to add?
Yeah, just really much more of the same. So our design today is assuming a launch to GTO, to the moon. And we are very moon focused, at least in the short term. I think there's plenty of science and exploration to do on the moon to keep us busy. But of course, a lot of the design aspects are very transferable to asteroids, other missions. So I'm sure in the longer term that will be something that we look at as well.
Okay.
Fred Perez, ASMS Incorporated. The question is addressed to AC. The gentleman from iSpace indicated the target dates that they have. Does Blue Origin have any target dates for their missions? And will I be able to use my Amazon Prime membership for delivery to my
Yeah, typically I start my talks by asking whoever here is an Amazon Prime member, please raise your hand. But thank you. On the second question, I'm not sure. We'll talk about it. What we publicly stated, Bob Smith, our CEO, in front of the National Space Council meeting, stated that we are looking at 5 years for the first Blue Moon mission. So I'd say that's 5 years from the start of the public-private partnership with NASA, as we've outlined it. So we are looking for a capability within the next few years to do that first Blue Moon mission. And once again, we're open to different launch vehicles that first mission could go on. So,
Thank you.
Thank you. Dennis.
Question for AC. What's your TLI capability for new Glenn? And is the upper stage going to do possibly lunar insertion? Or 3, will the platform, the Blue Moon platform, be available, let's call it as an OEM feature, to where people could put their own payloads on it?
Yeah, so at Blue Origin, we take a step-by-step approach. So some of the questions I cannot answer, but not under.
I'm going to keep asking.
So, I know you will. So under NDA, I could probably answer the TLI question and some other questions. We're definitely looking at Blue Moon to be a capability people can purchase. We're not looking for this to be a PI-led endeavor kind of project. It is a service. It is a lander capability a PI could use on a proposal for an announcement of opportunity. So we're definitely open to providing it to folks as a platform and purchasing the service or purchasing the product from Blue Origin for Blue Moon. So we're definitely open to that discussion. And if people have ideas for payloads that take the entire capability, that's fine. So we're definitely open to those conversations. So.
Okay, Pascal Lee. So I have 2 questions, but they are related. First one to all 4 of you. Do you have specific plans to combine your landers with surface mobility systems? Or is this something that's completely left to the paying customer? So in other words, I see that you can transport rovers, for example, to the surface, but do you have a preferred robotics partner for that, or do you plan to develop your own? And then the question for Alain specifically is, you showed us a multiple combined lander configuration. Can that do multiple landings on the moon as well?
Well, we start with Alain, and then we'll work it through the rest of everybody. No pressure.
No, fine. First of all, in terms of mobility on the surface or any other types of surfaces, because you can think of a landing platform may have some kind of common type of systems that could be useful for multiple missions. You could think of sample acquisition and handling, for example, mobility to go get something a little bit further away from the deck. I think there's no strict philosophy of us owning a certain service or not. A customer could come with their own service that would do that, and they could sell that service to another customer that may have a payload on top of their service, but it may not be exclusively that way. We could end up creating a partnership or developing a certain capability ourselves. So we're not locked into one way or the other. The multiple landings on the surface, again, we're looking at all that stuff. We're looking at the role of the Deep Space Gateway. We're looking at being able to shuttle back and forth. We're looking at being able to have a kind of a turret system where a number of these would be able to come up from the surface in different scenarios. So there's a lot of flexibility because of the modularity of the single module that can do a lot of different things.
Okay. Let's go to Jamie with the other question.
Thanks. So yes, for iSpace, I think one of our key advantages at the moment is we have this great synergy between our rover, which is already developed, produced. In fact, we've brought one of our models with us from Japan for this workshop. Hopefully we get to present it at some point. And with the lander. So certainly just now we're designing the two to be compatible, of course. As well as the current version of the rover which we have today, we're already in quite advanced stages for future rover missions. Like I mentioned, with the Luxembourg office and a neutron spectrometer mission, which needs a slightly larger scaled up rover from what we have today. But also, of course, we're very happy to host rovers which aren't iSpace manufactured. Fundamentally, we want to have a transportation service. We will have a rover which can do that for customers, but we're happy to look at other options as well.
Okay, we see a lot of people standing up. This is going to, the 5 of you that are there, well, 4 of you now that we've dealt with Pascal. Sorry, we're going to take, yeah, you're done. Sorry. But you can ask your question of these folks that are around at the poster session, maybe. Dan, let's go with you next.
Yeah, so the answer is yes to both. So we offer a very modular delivery vehicle. There's a wide range of options to be able to have rovers that are built by the customer, and we do have customers that are signed on to do exactly that. But we're also developing in our future missions and technology division at the company a new standard called Cube Rover, which I'll leave to them to maybe discuss a little bit further in the poster session, but we're really creating a new standard, as the name sounds, similar to a CubeSat, in that there's a number of kind of exciting things that can be done at a small and micro level, and utilizing a new platform that can be standardized and used by space agencies, companies, governments, universities. It doesn't really matter. So that's a standard that we're working and building right now. We have a contract actually with NASA to develop that now. So glad to talk about that further offline as well.
Tracy?
Yeah, we're really focused on that first major step, which we believe is the descent stage. That a large, very capable, highly evolvable descent stage capabilities is our in current kind of large area of effort. We're not really looking at surface mobility systems right now. That could be something we expand our capabilities to, but for right now, I think we're really focused on that descent stage and getting these customers, whether it's a surface scientific payload, a part of a lunar network, the Resource Prospector rover, as I mentioned, is a possible point of departure rover that we could easily deploy from the first mission of Blue Moon. Those are the kinds of payloads we're looking at, and we're open to having conversations with folks for the various payloads they might have.
Very good. Go ahead.
Thanks for your insights. I had 2 questions. The first question was concerning the landers for the planetary protection of or lunar protection. What measures are you taking, whether it's like NASA guidelines, international guidelines, as you guys are international cooperations? The second one was going beyond the science. So I call it like inspiration and the space inspiration. So it was cool to see Astrobotic and Dr. Lee's space arts programs integrated. And when you look at explorations for the US, it was also like streets gilded with gold, et cetera. So how are you guys going to brand the moon, so to speak, as a platform company?
Yeah, I guess I'll start. So we were founded to make the moon accessible to the world, and we truly mean that in the sense of the world. We, as mentioned, have 6 countries that are represented, which we think is a pretty significant milestone for humanity, because there's been, of course, 3 countries that have soft landed on the surface of the moon. With our first mission, we'll more than double the access for everyone. So that's kind of the main sort of drive of what causes us to get excited to want to go to work every morning, is to create access for everyone. And we're doing that with the contracts that we have in place right now and more going forward.
I think several years ago, NASA had promulgated, maybe 9 years ago at this point, a series of guidelines for folks and operations around the Apollo sites or the heritage sites. We definitely look at that document and take that in as guidelines and guidance that we'll take to be a very respectful operator on the lunar surface. So I think there's some interesting guidelines NASA's provided, and we're using that, and giving that to our design teams, and as we look at sites and be kind of appropriate actors on the lunar surface. Once again, for us and others to use.
Just as further clarity, I was just like referencing maybe Nike collaborations, like your DHL, like Air Jordan on the moon, maybe Red Bull, something like.
Absolutely. I mean, that's we have not only DHL, but we also have another commercial company in Japan that's doing sort of a marketing campaign to inspire children. So that's exactly in the line of what we want to enable. We want to make access available for everyone to carry out a whole variety of new visions, not just one particular strand that wants to go to the moon.
Yeah, so I'll take the second question. So yeah, in terms of branding, I think it's something iSpace have really at the forefront of what they're doing. As an engineer, I have to say I was quite skeptical when I joined the company. They almost had as many people working in PR and business as we did on the engineering side. It's like, this is totally new for me, but it's actually paying dividends. So perhaps over in America, not so known, but in Japan, there's a huge amount of effort and engagement with the public in terms of partnerships, in terms of fundraising. And of course, we had a very successful fundraising at the end of the year, but also that's gained us a lot of commercial partners from all different industries. We actually have a really nice video. I didn't have time to show it today. It's on our website, showing all the different industries which we believe, not just advertising, but could be involved in this lunar economy. And we've managed to convince those people to be investors, to be partners, to be sponsors. So it's something we take very seriously.
Yeah. Lunar drones could be interesting with DJI.
Yeah, we're gonna. Last 2 questions.
Yeah, so this is a question geared more towards resource extraction. So there's a significant lack of kind of policy regarding commercial exploitation of the moon in terms of extracting resources from it. And it seems like a lot of the policy in this area is kind of like companies mentioned, like, oh, the U.S. government has granted us, this right to resource extraction in some area. That's kind of like a unilateral action by the U.S. government. I guess first, do you think this view that the U.S. government acting unilaterally to kind of restrain the moon's resources, is that like how the atmosphere is currently in that field? And 2, do you think like that's the path forward that we should be taking?
I'm just the moderator, so I'm gonna
I'd be happy to try. First of all, Moon Express has been working hard with the U.S. government to make sure that when Moon Express does this, we're going to set a standard, set a model for responsible commercial activities on the moon that follow international treaties and national laws. The U.S., when it acted over the last few months to give Moon Express its mission approval to go ahead and be the first commercial company to go beyond low Earth orbit, didn't do it unilaterally. It is based on the Outer Space Treaty that the U.S. Is a co-signatory of, that describes very carefully what the responsibilities of nation states would be if they give that approval for those companies to those commercial companies to go forward. There's a lot of work to be done. There's a lot of work that we did, and the U.S. government did a lot of work to blaze the trail for the future. But it is really important, I'm sure, to all of us. I don't want to speak for them, but I'm sure it's a fundamental tenet of all of us to do this carefully and to do it in a way that that makes sense. Now, at the same time, these are commercial entities, and the parallel to the high seas is relevant and is applicable to the way we we're going to be doing business in the future. Love to talk about it more. We could fill a whole day on just this stuff.
Yeah,
but it is a
won't.
it's a good question, and it's very important to the way we're moving forward. But it's not as unilateral as you've described it.
Well, I'll just add, I mean, I won't pretend to be an expert in US space policy as a European working for a Japanese company. But what I would say is, certainly in my personal opinion, we had a very interesting talk this morning on policy and responsibilities. There's a lot of open questions that obviously have to be addressed as we move forward, and that's certainly bigger than any one country. It's something that has to be addressed on the international stage. iSpace are involved in some international bodies which exist for these kind of discussions. We certainly want to be involved in that in the future. Yes, I think certainly unilateral decisions and actions is not necessarily the best way forward, I think.
Anything to add, AC? No? Okay. All right, thank you. Last question.
Yeah. Hi, I'm Rich Pisarski from the NASA's SBIR program, Small Business Innovative Research. And this is not a question, it's just a shameless pitch. Please consider looking, since we have the commercial folks up there, there's a lot of companies that we have in our portfolio over the years that have done high data rate communications. We've got a bunch of companies that are actually on Mars, on the existing rover, and also for the 2020 Mars mission, there's companies proposing things. To consider working with them, you also can have university collaborations with small companies, and our solicitation's coming out tomorrow. So please take a look at it. Thank you.
All right, thank you very much, everybody. It is, well, lunchtime. I do want to thank our panelists. I'm sure there are lots of questions. I know I have a lot, but it is lunchtime.